Everybody, just wanted to give you a quick rundown on my new packing facility. This is for Project Inidium, which I have published a little bit about. What it does is a little class file engineering. What you want to do is select a class that contains a main method, and this is the bytecodes produced by your compiler. In the case of IntelliJ, it's under the output production in the package that you're interested in, and you hit open, and that identifies both the class name and a new jar file name. You save this off to your settings, and then you proceed to do a pack. And what pack will do is include only those classes which are made reference to using static dependency analysis. The static dependency analysis on this one particular class, a ULaw codec, it's fairly independent, very small, especially when you compare to the larger project, which has over 8,000 files in it. So this makes a very compact mechanism for reducing your jar file size. But here's the next interesting bit. We use the jar file to then determine which source code we need in order to be able to compile properly. So we hit Optimize Source, and then what it does is it generates a mechanism for compiling that source code. It also generates an src.jar. When you go into your directory and you expand src.jar, what you find is a mechanism in place for compiling the code. It's been created with a very large class path that contains fully qualified path names. If you source compile.so, you'll get some warnings if you're using the Sun packages as I'm doing. Not supposed to do that. They're internal and proprietary. Naughty. And then what you can do is you can proceed to run the program. And that works. Moreover, you can see what is exactly included in the compiled code, and the answer is just one or two classes there. And in comparison to what it used as the input, it's quite large. For example, if you go to the SRC for the main project, you see perhaps 8,260 files, and this is correctly identified the two files that you need in order to get a correct compilation, a minimal compilation. Naturally enough, static dependency analysis can be defeated by the pathological adversary who is interested in doing reflection, class for name based on a string, for example, dynamic class loading. All that stuff will cause it to fail. Moreover, the number of different jar files needed may have to be uploaded to a server if you're going to deploy, as I have done using Java Web Start. So that's an interesting way to go about distributing the code. It all gets put into an src.jar. And if you look at the src.jar, you'll see what's in it. And it's these two Java programs and a manifest, and that's it. Moreover, it outputs an optimized jar file. The jar file is named for the class with a fully qualified class name, including the package. So java-jar includes a manifest so that you can run the program directly. And so that's a great way to deploy. And you can see the sizes here are very minimal, about 6.5K or 4.7K on the system. Hope you like my little demo. Thank you. Boy.